All right, let's get into one of the biggest, most mind-bending ideas in all of science fiction. We're talking about a thought experiment on a truly cosmic scale. And I don't mean just the solar panels on your roof. I mean all of it. Every single photon, every single watt of power our star blasts out into space every second of every day. What would you even do with all that power?
Yeah, that number on your screen, it's kind of hard to even wrap your head around. That's the sun's energy output. It's so much power that in just 1 second, it puts out more energy than humanity has used in its entire history. Tapping into that, well, that would change literally everything.
See, this isn't just about finding a better way to keep the lights on. This is about the future of our species, about fueling our evolution into something more. It's about what a civilization can truly become.
So you might be wondering, why would we ever need to try something so ridiculously audacious? Well, the answer starts with a problem we're already starting to run into.
The thing is, as we advance, our appetite for energy just grows and grows, exponentially. Our sources here on Earth, fossil fuels, nuclear, even all the renewables combined, they all have a ceiling. Sooner or later, we're going to max out what our little planet can give us.
And this brings us to the brilliant physicist, Freeman Dyson. He looked at this future energy crisis and came to a really simple but powerful conclusion. If you need more power, you've got to go to the ultimate power source, right in your own backyard, your star.
Okay, so problem identified. We need more juice. Power source identified, the sun. But how do you actually harness a star? This is where things get really interesting, where science fiction starts to become theoretical engineering.
In principle, it's a pretty straightforward idea. You build a structure around the sun to catch all that energy that's just flying off into empty space. Simple enough, right? Well, in practice, it's probably one of the most complex engineering challenges ever imagined.
Now, this is a really important point. The popular image of a Dyson Sphere, a giant, solid metal ball encasing the sun, is actually the least likely version. That's a Dyson shell. It would be incredibly unstable and probably just fall into the sun. The much more plausible and scientifically accepted idea is the Dyson swarm. Think of it less as a shell and more like a massive, dense cloud of individual orbiting solar collectors.
So for the rest of this little journey, when we say Dyson Sphere, what we're really talking about is this: a colossal, orbiting swarm of countless machines working together.
Okay, we've got the blueprint for our Dyson swarm. But how in the world do you actually get started on what would be, by far, the largest construction project in human history?
I mean, think about it. We're talking about building enough stuff to literally block out the light from the sun. You can't just order that much material from a warehouse here on Earth.
Yep, you heard that right. The most efficient way to get all the metal and rock we'd need is to deconstruct an entire planet, and Mercury is the perfect candidate. It's loaded with iron and silicates, and it's already nice and close to the sun, our construction site. And the plan itself is just mind-boggling. You'd start by mining Mercury, basically taking it apart piece by piece. Then you'd use enormous electromagnetic catapults to launch all that raw material into orbit. Waiting there would be fleets of self-replicating robots that would catch the material, build the collectors, and then build more robots. Slowly but surely, you'd assemble this swarm until it blankets the entire sky.
Of course, let's be real for a second. This slide here shows just a few of the minor details we need to work out first. Little things like how to keep trillions of objects from crashing into each other, or how to protect the whole thing from asteroids, or developing AI smart enough to manage it all for thousands of years. No big deal, right?
But let's just imagine we solve all those problems. We actually pull it off. What's the reward? What kind of civilization do we become? This isn't just another technological step forward. This is a fundamental transformation. We would literally graduate to a new tier of civilization in the universe.
This whole idea is summed up perfectly by something called the Kardashev scale. It basically ranks civilizations by how much energy they can use. A Type 1 civilization uses all the energy of its home planet. Right now, we're not even a Type 1. Building a Dyson swarm would launch us straight past that directly to a Type 2 civilization, a species that controls the entire energy output of its star.
And with the power of an entire star at your fingertips, well, the projects that were once pure fantasy suddenly become possible.
You could terraform planets, control the climate, build ships that could actually reach other stars, or even run simulations of entire universes. Your only limit is your imagination.
Okay, this all might sound like something from a far-off, distant future, but this last part connects everything back to real science that's happening as we speak.
Believe it or not, we are already searching for these things. When astronomers at programs like SETI scan the skies, they're not just listening for alien radio signals. They're also looking for the telltale signs of a megastructure, a star that dims in a weird way or gives off a strange heat signature. That's the waste heat a Dyson swarm would produce.
And that leads us to a final and honestly kind of chilling thought. So far, after all that searching, we've found nothing. The universe seems quiet. So why?
Could it be that reaching for this ultimate level of power is some sort of great filter? A final test that maybe no one has passed yet? It's a heck of a question to think about. Is harnessing the power of a star simply too much for any civilization to handle?